my cracker yet.
I get my homework done when
Okay, 5-3 inverse functions. So we're going to verify that the functions are inverses, and we are going to find their inverses. And we are, actually, there's a little bit of calc just because it was reviewing what we already know, but it's not like new. Nothing new.
No.
Can you stop? I'm recording.
Is there algebra?
Yes. Okay, so inverses, there has to be algebra. Okay, inverse functions, remember the domain and range physically interchange places. That's what happens with them. So what we know is if we had inverses, if I do f of g of x and simplify it, I get x. And if I do g of f of x, I get x. And that has to happen. Okay? To verify, you have to do both things. Because the domain of one becomes the range of the other. Remember we talked about, I'm always like picking them up and moving them. So if f of x, the point is -7, 6, f prime of x, meaning the inverse, it is what?
6, -7.
6, -7. Okay, that domain and range, that x and y, physically interchange places. Let me know when you guys are good.
I'm good.
Oh.
Sadie, are you writing every word again?
That's
Okay.
just most of them.
Are you
I'm also a slow. I'm just.
Yes, I am. That grape one. Give me that grape one. Because I know you don't like grape.
You want all of the grapes, actually?
No.
I wasn't talking to you.
No, I mean, she doesn't want them because I want them.
Okay, so we need to show that they're inverses. So we need to do f of g of x and g of f of x. You have to do both. So f of x is 2x cubed minus 1, and g of x is the cube root of x plus 1 divided by 2. Now you can leave that cube root as a cube root, or you can take it to the 1/3, whichever way you would prefer to do it. Oops. So we're going to start with f of g of x. So my x is the whole function, right? So I get 2 x plus 1 over 2 to the 1/3, and then I'm going to what? Cube it?
Yeah.
Minus 1? So I get 2 times x plus 1 over 2 minus 1.
Can you explain your steps there?
I have 1/3 of 3. I have 1/3 because it's the cube root.
Okay. So then doing your cube roots just...
Yeah, because 3 times 1/3 is 1. Now what?
Distribute?
You could, but what would be easier?
Cancel it or reduce the 2.
Reduce the 2's, right?
Oh. Sharp C.
So then I got x plus 1 minus 1 is what?
X.
X, and that's what it's had to be, right?
Yeah.
So now we have to do g of
F of X.
f of x. So we have the cube root, right? Of x. What's x?
The entirety of F.
Yep, so 2x cubed minus 1 plus 1 over 2. Well, minus 1 plus 1 is what?
0.
0. And 2 divided by 2 is
1.
1. So I now have the cube root of x cubed, which is what?
X.
x. So are they inverses of each other?
Yep. Yeah.
Yep. Good? Now we're doing this?
Yep.
Okay, so when that x and y interchange places, they reflect across that imaginary y equals x line, correct? That's just what it would look like. And that's the same picture again. Okay, so here are two things. A function has an inverse function if and only if it is 1 to 1. That means every x has one y and every y has one x. It means it passes the vertical and the horizontal line tests. And again, it says it has an inverse what? Function.
Yeah.
Everything has an inverse. It's whether the inverse is a function or not is what we're going to be doing. Okay? So we've done that before. We've looked at graphs, and I've given you something like this, and you've told me no inverse function because it's a function, but it's not a what?
Inverse.
It's not a 1-to-1 because it doesn't pass that.
Horizontal test.
But if I give you this, does this pass it?
Yes.
Yes, because there's no extrema, is there?
Nope.
This one over here is monotonic. Remember, that's increasing over the entirety or decreasing. This one is not. So, no extrema. So, what did we do to find extrema before?
Did we equal the first derivative to 0?
Yes, good job. So we equaled the first derivative to 0, okay? So if it has extrema, does it have an inverse function? No.
No.
If it doesn't have extrema, does it have an inverse function?
Yes.
Yes. So that's what we're going to do. It's going to say which function has an inverse. So we're going to take the first derivative. So f prime of x cubed plus 3 minus 1 is what?
3x squared plus 1.
So 3x squared plus 1. So I would need to set that to 0, right?
Yep.
So I would subtract 1, divide by 3.
Yeah.
So x squared equals negative 1/3. Then what would I do?
Multiply by 3.
Nope. You just divided by 3. I need x.
Oh, yeah. Square root. Yeah.
Take the square root. Now, what's wrong with taking the square root of what I just did? It's a negative, and I would have an imaginary number, yes?
Okay.
So do I have any extrema?
No.
No. So I have no extrema. So it has an inverse function. Can I just write f of x?
Yeah.
So the next one, x cubed minus x plus 1.
That'd be.
So f prime. Now, we got to keep f prime. I probably should have wrote dx, ddx. Because why? What does the derivative look like? Doesn't it look like inverse? Isn't prime for inverse?
Yeah.
Yes. And we got to keep that straight. I normally can keep it straight just fine, but you need to make sure you are keeping it straight. Okay, so ddx would be
3x squared minus 1.
okay, so then I would add 1, divide by 3,
Yes.
and then take the what? Square root. So I get x equals plus or minus 1 over the square root of 3, which would be the square root of 3 over 3. So does it have extrema? Yes. So does it have an inverse function?
No.
No. Because this, at negative and positive, there is an extrema. I don't know if it's a min or max, but this function looks like this. Something like this, right?
Yeah.
That's horrible looking. Would it pass both the vertical?
No.
Okay.
So if it's not inverse, it passes both vertical.
No,
and
if it
horizontal.
has an inverse. If it has, it has to pass
Oh.
both. This graph goes over here.
Okay.
Okay, right here. Has to be 1-to-1, meaning it passes horizontal and vertical. Okay? Questions? Last thing, last example. Okay, this is just your guidelines for finding inverses. It's not something that you specifically have to say. It kind of is a bunch of mush there, I think. Inverses interchange domain and range, yes? X and Y?
Yeah.
So to find inverses, I interchange what?
X and Y's.
X and Y. So all the Y's become X's, all the X's become
Y's.
Y's. So f of X is the same as a Y, correct?
Yes.
So we're going to make it X.
Oh.
I'm going to make it X equals the square root of 2Y minus 3. Because X and Y, and then I have to solve for Y.
Yes.
Okay? So how would I solve that for Y?
Square it.
Okay, so square both sides. So I would get X squared equals 2Y minus 3.
Yes.
Then?
Divide by 2.
Nope.
No. Add 3 to
Add 3, then divide. You got to have it by itself first. So the derivative, the inverse would be X squared plus 3, all divided by what?
2.
2.
Y.
No, just 2.
Oh.
Y stays by itself.
Okay.
That's it.
That's all?
That's it. That's all I got for you.
Wow.
Wait, do we have to write? Do you have to write all those down, like the guidelines? Like,
No,
is it just interchange X and Y?
it's just an chug.
It's just up to you, Sadie.
These guidelines are in the book if you feel that you need them in your notes.
You do not even need to take notes today. I thought it was helpful.